right, so for our last tree diagram example, this time we're going to select marbles with replacement. So that means that after we selected one, we're going to put it back in the bag that contains all the rest of them, and we do have a possibility of selecting the same one over again. So that means that we have 4 options for our first color, and we also have 4 options for our second color. It's going to give us a total of 16 sample points. Right. And our tree diagram is going to start the same way it did in the first page, where we're going to start with either red, blue, orange, or green. The difference is here, instead of having 3 branches of the different colors off of there, we're going to have 4 total. So red, blue, orange, green, oops, red, blue, orange, green, red, blue, orange, green, red, blue, orange, green. All right, so what we have here, we had 4 options for the first one, times 4 for the second one, which gives us a total sample space of 16. So now I'm going to go ahead and list out my sample space. All right, so we're going to have red, then red, red, then blue, red, then orange, red, then green. Blue, then red, blue, then blue, blue, then orange, blue, then green. Orange, then red, orange, then blue, orange, then orange, orange, then green. Green, then red, green, then blue, green, then orange, green, then green. So we have all 16 elements in our sample space. All right, so now we're going to find a couple of probabilities. All right, so our first probability, determine the probability that a red marble is selected twice. So red followed by red. Well, we only have 1 of those. Right, so red followed by red is going to be 1 out of 16. Trying not to cut my sample space off here. Right, determine the probability that neither marble selected is orange. All right, so our red case is not orange. Red then blue does not include orange. Blue then red, blue then blue, green then red, green then blue. And then we also have, the whole row has oranges, so red then green, blue then green, and green then green. Right? So what we have here, what we see, if we count total the numbers that don't have an O in there for orange, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of getting neither orange is going to be 9 out of 16. Right. For E, determine the probability that the orange marble is selected at least once. So that means it could be selected once or it could be selected twice. Instead of underlining these, in this case, I'm just going to put little dots by these. Right, so that one has an orange, that one does, this one has an orange, that one does, this one has 2 oranges, orange and orange. If we look at this, what we've just marked are the ones that we didn't use in part D. So our answer for E, if we count all of these up that I just put a dot next to, we have a total of 7 out of 16. Remember that we've talked about complements. Complements are the relationship between 2 events, one that does happen, one that does not happen. So one alternate way we could have answered part E, right? We could have said that the probability of our event happening at least once is 1 minus the probability that the event does not happen. So the probability of at least one orange is 1 minus our probability of neither orange. Right? And 1 minus our answer to B of 9/16 gives us our answer to, or excuse me, D gives us our answer to E of 7/16. So remembering that this relationship between none and at least one is something that could quite possibly come in handy. Pay attention when you are constructing your tree diagrams. If you see the words with replacement or without replacement, as that could also make a difference in your type of sample space that you get in your tree diagram and then your final answers.